When the federal government selects solutions to help reduce energy consumption and environmental impact in today's buildings, innovative design and advanced technologies are essential. But with so many energy efficiency claims, there's one thing that is even more critical: proof. Thanks to the General Services Administration, or GSA, building owners and operators can look to the GSA's Proving Ground Program, or GPG, to find exactly that. One of the GPG's most recent and significant studies focused on determining which type of water-cooled chiller technology is more efficient and reliable. The Proving Ground program developed a head-to-head test of two water-cooled chillers of equal capacity. First, a Carrier variable speed screw chiller made in Charlotte, North Carolina, referred to as VSS in the study, which features direct drive and surge-free compression, thereby eliminating mechanical unloaders. And the second, a mag-bearing variable speed centrifugal chiller referred to as MBC in the study. These chillers were evaluated in a side-by-side comparison in the Sidney Yates Building, headquarters for the U.S. Forest Service in Washington, D.C. With Oak Ridge National Laboratory direction, instrumentation was installed to measure cooling capacity, operating temperatures, and chiller energy consumption. Both chillers were connected to the same chilled water and condenser water loops, allowing for an objective comparison of operating efficiency, reliability, and sound across a broad range of operating conditions. After an entire cooling season of testing, the results were in, and they were significant. The Carrier variable speed screw chiller demonstrated 11% efficiency improvement over the mag-bearing chiller, with greater versatility under different operating conditions, fewer maintenance requirements, and comparably quiet performance. First, let's look at energy consumption. While the chiller submitted IPLV ratings, which are commonly referenced as an indication of efficiency, were within 1% of each other, actual results showed a much different story. The Carrier chiller had an energy consumption rate that was 11% lower than the mag-bearing chiller, significantly more savings than submittal data would indicate. It's also worth noting that these savings are on top of a Carrier chiller equipment cost that was more than 30% less than the mag-bearing chiller with the same cooling capacity. The savings become even more impressive when you think about them in the context of your existing chiller plant. Here's what we mean. An earlier GSA study in 2013 showed mag-bearing chillers to be 42% more efficient than the old constant speed screw chillers. Add the 11% gain in efficiency reported in this study, and the Carrier chiller offers total improvement of nearly 50% versus a chiller nearing the end of its useful life. When put to a stress test, the Carrier chiller showed greater operating versatility, providing an increase in system reliability. At entering condenser water temperatures of 95 degrees Fahrenheit, the Carrier chiller operated normally without any signs of distress. The mag-bearing, however, had a compressor trip offline. When conditions demanded low condenser water temperatures, the Carrier chiller was able to satisfy building cooling, while the MBC manufacturer recommended not doing a startup. The results illustrate the Carrier chiller's ability to operate reliably throughout a range of temperatures well above or below design conditions, earning the VSS compressor the distinction as a universal design. The Proving Ground study also kept track of maintenance records and ongoing conversations with the site operations team to gather their overall impressions of the two units. While both units provided appropriate temperatures and operators received no complaints related to comfort, the Carrier chiller required less unscheduled maintenance than the mag-bearing unit. The mag-bearing chiller required repair of mechanical unloaders. The Carrier chiller technology does not use mechanical unloaders, removing this source of inefficiency and potential mode of failure. Because every building is different, the researchers operated chillers over a wide variety of conditions to simulate buildings around the country, making the VSS technology widely applicable to facilities in all climate zones. VSS energy savings were seen across varying load and condenser water temperatures, with significant savings in the 40 to 60% of full load range where many chillers spend the majority of their time. In fact, based on the findings of this study, the VSS chiller's ability to tolerate swings in condenser water temperature may make it especially valuable for critical applications such as data centers, high-security facilities, or facilities that must operate 24/7, 365. The VSS chiller demonstrated its ability to tolerate these swings and continue providing chilled water. At the request of other suppliers, the research team performed additional due diligence, including National Renewable Energy Lab's third-party review of test methodologies and data analysis, all of which affirm the conclusion originally reported in GSA Proving Ground Report number 31. In summary, the GSA Proving Ground findings on water-cooled chillers highlight the benefits of Carrier variable speed screw chiller technology, 11% greater efficiency, quiet and reliable operation over a wider range, and no mechanical unloaders, all with a lower cost. These findings shatter the common misconception that magnetic bearing chillers are the industry standard for efficiency and proves Carrier variable speed screw chiller technology sets a new level of performance. So when you're looking to select new solutions to increase performance in your building, it makes sense to start by looking at the proof. Read the full study today